Hello, all. Welcome to the ninth standard science classes on gravitation. It's a second part of the series on gravitation. Gravitation is covered as part of chapter 9 in CBSE syllabus and chapter 10 of Karnataka state syllabus. I am strictly adhering to the syllabus provided by the school books. As we went through in the last class also, this gravitation has six topics: gravitation, free fall, mass, weight, thrust and pressure, and Archimedes principle. In the first video or class, we learned gravitation and universal law of gravitation. In this video or the class, let's focus only on free fall. Okay, let's come to our core topic of this class: free fall. Okay. Uh, Before getting into free fall, let's refresh our the concepts which we learned in our previous classes. One is what is gravity, then how does gravity affect the motion. Third one is what is acceleration due to gravity. Fourth one, again our main topic, free fall. What is free fall? Okay, let's start with gravity now. Okay. Uh, what is gravity? Gravity is a force. We know that. What is simple? What is gravity? Gravity is a force. Okay, that pulls objects towards the earth. Look at it. If you assume yourself as an object, earth, all the objects are falling towards the earth. Okay, and why they are falling towards the earth, right? So it's a force. Some force is okay pulling the objects towards the earth. That's what we call it as gravity. Gravity is a force that pulls objects towards the earth. Okay, next, what is the formula? We derived this formula, right? Previously, based on Newton's principles, right? So what is this? What is this? Gravity is a force, he said, right? Gravity. So the force, I should write a formula for the force. Okay, and it is very clear as Newton's revealed. Gravity depends on mass and distance of the objects. So it means F is proportional to mass and F is inversely proportional to distance. It means gravity is a function of mass of the object and distance of the object. Okay, it means you have a, this is a different the object, this is a different object, he is a different object, this is a different object. So everybody's mass is different, and people, and they are at different heights from the the earth, right? So it means the distance is different and their mass is different. Definitely each one will the the feel a different force of attraction from the earth. Okay, gravity is stronger when the objects are closer. Why closer? Why they are stronger? Because F is, what is F? F is closer. Closer means D is small. F is inversely proportional to D square, correct? Here. F is inversely proportional to D square, right? F is inversely proportional to D square. If D is small, it means distance is small. It means if the two objects are very closer, it means distance is small. So F is inversely proportional to distance. If D is small, force is very high. I told you last time session, right? If distance is reduced by 2 times, okay, 2 times, force gets multiplied by 4 times. If the distance is reduced by 10 times, force get multiplied by 100 times, square terms. Okay, so that's how. Okay, so the gravity is stronger when objects are closer, very clear, right? At the same time, gravity is stronger when the objects are heavier. Heavier means more mass. More mass means, look at, F is proportional to mass. So heavier means more mass means more force. As simple as that, right? Gravity is stronger when objects are closer and heavier. Let's go to the next topic. Let me clear this up first. Right, great. So now, okay, how gravity affects velocity of falling objects. We know what is gravity. Gravity attracts. First, the first para. Second para. How it affects the question now, right? So now, gravity affects velocity of the falling objects. It attracts, but It also attracts the speed at which they fall. Okay, gravity affects velocity of the falling objects. Remember, velocity and the speed are very similar terms. Okay, so how it affects, we already know it, right? We know the formulas, right? So velocity, what do you mean by velocity? Velocity is speed, and it's also direction. Okay, we should, velocity is a speed, and its course, it has a direction also. Okay, so how this is a formula generally we write. Okay, so gravity does not change the direction. Remember, gravity will not change the direction of the body. It will only change the speed of the body. Important thing, right? Gravity makes objects fall faster as they get closer. Why? Because we told, right? So gravity change the speed. It means if the object is falling from here, it can be speed 1 here, it can be speed 2 here, it can be speed 3 here, it can be speed 4 here. It means this gravity is changing the speed of the same object over a time. Okay? As object moves towards the earth. Gravity makes objects fall faster as they get closer. Is it the speed velocity is increasing or decreasing? It is increasing. This is falling at lower speed, whereas here the same body is falling at faster speed. Okay, as the object moves towards the earth, gravity makes the object fall faster as they get closer to the earth. It means distance t. How? There are two ways to understand it. Here, assume this the same body is already here, the distance is small, right? So distance is small, force is more. One way to look at it. Okay, and of course moves faster. Second way to look at it is, this is what? V is equal to U plus GT, where U is the initial velocity. Ignore it for now. Okay, V is equal to GT. What is that? V is equal to GT, where G is acceleration but due to gravity. Now G is constant, correct? So we can write it as V is proportional to T. See, earlier it was T is equal to 0, T is equal to 1 second, 2 second, 3 second, 4 second. T is increasing. So it means the velocity of the body also should increase. Okay, there's a second way to look at it. Why? The gravity makes objects fall faster as they get closer to the earth. Okay, as they get closer to the earth, one way to look at it is distance is reduced, so force is more. Second way to look at it is time elapsed is more, so velocity is more. Okay, right. Next, get into next into the acceleration due to gravity. Let me clear some of this stuff. Right. Clear. Okay. So let's do that. What is acceleration due to gravity? Acceleration, you know that by definition, acceleration is what? It's a rate of change of velocity, or the rate at which velocity is changed, or change in velocity with respect to the divided by change in time. Correct. So many ways to put it. We can say delta v by change in velocity by delta time. We can also say dv by dt. Okay, it's the rate of change of velocity. Simply say in simple words. Okay, rate of change of velocity. The rate at which velocity is changed with, of course, with respect to time. Remember. Okay, as time elapsed. So now, what is we know learned what is acceleration, right? We'll know. Let's see at what is acceleration due to gravity. So acceleration due to gravity is what? It is an increase in speed by gravity. Simple. Both are same definition, but caused by gravity. That's all. It's increase in speed caused by gravity. Right. Let's go next slide. Acceleration due to gravity is same for all objects. It means it's a constant term. What is that? Acceleration due to gravity is same for all objects, whether heavier mass or smaller mass, solid or a liquid on the earth. Remember, regardless of their mass. Okay. Acceleration due to gravity is what? Denoted by g. Of course, we earlier we used to refer it as a denoted by a because it's for acceleration. Now we want to be a little bit specific, and this acceleration is caused because of gravity or due to gravity. I would be very specific in using what, just to differentiate with very generic acceleration with respect to this, due to gravity. I'll be using g. What is the unit? Meter per second square. Then what is value of g? Is it variable? It is a constant. And for Earth, this is always 9.8 meter per second square. And we use this constant term for calculating weight and speed, acceleration, everything, right? I think you understood now. Let's go to our main topic, free fall. Okay, what is free fall? Free fall, see, object falls. All these objects are falling here, right? Okay, what is free fall and what is very, okay, it is free fall is when objects fall towards Earth. Of course, they're falling towards Earth, but there's a condition here. There's a catch point here, right? Okay, when objects fall towards Earth, only under the influence of gravity, remember, only under the influence of gravity. Okay, free fall does not consider other forces like air resistance and friction. Okay, remember, you see our environment. For example, when just imagine yourself, dropping a ball from zero initial, rest, basically rest, right? It will touch the earth. It's, of course, you're not pushing it; you're just dropping it. Okay, removing your hand, right? But that's what we generally, by definition, we call it as free fall. That object is falling only under the influence of gravity of the earth. But in the real world, right, we have air, and air has got its own resistance, and the ball has to pass through or overcome this friction provided by the air, right? So in general, when we define free fall, we ignore or we don't consider other forces or frictions like air resistance. Okay, free fall is ideal. It means this situation rarely happens in real life. Why rarely happens? Because in our real world we have air and it provides friction. And, okay, we always ignore it because that is a negligible friction. Okay, so now to conclude, what is free fall? Free fall is when objects fall towards Earth only under the influence of gravity. Remember the keyword, only under the influence of gravity. When objects are falling, we say that they're free. It's the phenomenon is called free fall. Okay. Okay. See this guy. He's throwing the balls up, but balls are automatically coming down. Okay. He's not pulling the balls down. The balls are coming down because of Earth's gravity. That's how he's making use of Earth's gravity to show his magic. He's pushing up, but Earth is pushing down, right, and pulling down, right. So let's not go into the activity, but we know it already, right. Um, let's derive some formulas, or understand using mathematical formulas. This is free fall only. Okay, what Newton's second law says. See, Newton has three famous laws, right? Laws of motion. The second one is what? Second one is very famous, right? F is equal to ma. Okay, what it says, magnitude of gravitational force. This is a force, right? In this case, I'm calling it as a gravitational force. It talks in general. F is equal to ma. It's a very generic force. It can be between two bodies, any two bodies. In this case, between Earth and an object, which means I call it as Earth is attracting, so I call it as a gravitational force, right? A magnitude of the gravitational force, F will be equal to product of mass, right? What is this? Product of mass and product of acceleration. In this case, acceleration due to gravity. I'll replace A with G, right? So now I can write F is equal to, F is in this case what? It's a force, but in this case it's a gravitational force. And what is G? It is acceleration in general, but in this case it is acceleration due to gravity. I'll replace A with G. And of course, M is mass of an object which is falling, right? Okay. So now epsilon mg. Now we also know the formula. What is this formula? Universal. What is this formula? F is equal to g into m into m by d square. Okay, universal law of gravitation. We derived this formula also, right, in the previous class. So this is Newton's law of motion, second law of motion. This is again Newton's law, but this is be called as universal law of gravitation. Okay, so both are forces. Remember, both are forces here. But this formula we derived using, use the other way of derivation is g into m by d square, where m and m are two bodies attracting masses of the two bodies. Distance is distance between the centers of the two bodies. Of course, g is a constant. So it means we have a body here, we have a body here, they are attracting here. This is M, this is M, right? One form, one way to put it. What is the force here, right? Other ways put it is, assume this is your object and this is Earth, right? So this F is equal to mg. We can use it as, okay. Both are forces. Okay. I just listed them. Now because both of them are forces, and let's equate them. Okay, because in this case, this Earth, this is a some object, say ball. So this also for a formula for a ball. Okay, F is equal to m into g, where m is mass of the ball and g is Earth, acceleration. Right, now equating them, right? What is happening? Equating. So mg I can write mg is equal to, this mg is equal to g into m into d square. So now look at it. This is m. I can cancel. See, this m is Earth's mass. Remember, this m is an object which is falling towards the Earth, small mass, right? So now look at it. This f is equal to mg, and this also has got a small m, right? I can cancel them, right? What is the next equation? G is equal to g into m by d square, where g is a constant, okay, m is mass of the Earth, d in this case, assume it is a Earth, big Earth, you are somewhere here, right? Compared to this Earth radius, okay, what is your distance? Distance is assumed is x, some x, right? What is distance? Is equal to r plus x, right? Okay, imagine this is many million kilometers, and you have 1 meter, many million meters plus 1 meter. We say ignore this x. I'll say distance is equal to radius of the Earth. All right. So now what is g? G is equal to m. Small g. The acceleration due to gravity is equal to g into m by d square. So where I can see, if the object is on the Earth, I can simply replace d with radius of the Earth. Simple. Okay. So where m is the mass of the Earth, d is the distance between the object and the Earth. You know that, right? So thus, let me clear the map. Now what's happening here? What's happening here? Okay, in case the object is near a surface of the Earth, the distance in d is equal to radius of the Earth, correct? I told you, right? Assume you have assume for a moment the radius is say 1000. It's bigger, remember? I'll tell you the number later. Assume it is number, and you are just above 1 meter. Say assume the radius is 10,000 meters, and you are just 1 meter above the radius. What is total? Approximately equal to 1000 only, right? Approximately equal to. Okay, the error is negligible. So I'll simply replace d with r. D, okay, r of the radius of the Earth. Thus, for objects on or near the surface, if it is on, the extra is 0. If it is 1 or 2 meters, I can ignore it. Okay. Equating Newton's second law of motion to universal law. These are the equations. Okay. Mg is equal to g, same. This gets cancelled. Same thing as this. G is equal to, what is this? G is equal to, small g is equal to g into m by r square. Remember, m is a mass of the Earth, constant. Radius of the Earth, we know it pretty much. Okay. G is of course constant of proportionality. All of them are constant. It means if I calculate, g remains constant, which we get it 9.8 meter per second square. We'll derive it later in the next class. Okay, let's all summarize what we learned till now. Okay. We learned F is equal to mg. What is this? Force is equal to ma, Newton's second law of motion. Okay, where acceleration got replaced by acceleration due to gravity for a falling object. Okay. Second, we universal gravitation, law of gravitation. Right. What is this? Again, both of them are given by Newton. F is equal to, F is proportional to masses, product of masses, inversely proportional to distances. Look at this, again also it's proportional to the mass. Okay. Now if I equate them, we get this formula. Okay, what is this? This acceleration due to gravity. If I want to do, it means what is acceleration due to gravity? Rate at which an object is accelerating towards the Earth, a falling object, all accelerating towards the Earth. That is equal to what? It's a constant. Look at it. because all three are constant. G is constant, M is constant, D square is constant in this, right? Okay, right. So now equating them, we get for as any object on the earth or very closer to the earth, okay, we replace distance with r square. Okay, note. What is this note? Earth, but see, earth is not a perfect square, remember. So it means, is it r is same for all every places? Assume it's earth. Okay, is it radius is a perfect square? Sorry, perfect sphere. If it is perfect sphere, r I can take it as constant, but it's not constant. It's not a perfect sphere. So depending on the places, r can be different radius, right? What is radius? What is radius? Point to this, point to this, point to this, point to this, point to this. Who knows? This may not be equal to this. Okay. The radius of the earth increases from poles to the equator. Remember, from this point to this point, from this point to this point. People say the radius here in the center equator is more compared to the radius of the earth in the poles region. Okay, so when radius is changing, naturally the constant changes. Okay, it means what? The radius is more at the equator. It means G is less at the G equator and G becomes greater in the equator. Okay, why? Value of G becomes greater at the poles. Sorry, that's correct sentence. Okay, so we simply say what is the acceleration due to gravity? The acceleration due to gravity is more at the poles compared to the equator. It is a takeaway. Acceleration due to gravity is more at the poles compared to the equator. Why? Because the radius, a sphere is no, Earth is not a perfect sphere. Radius of the Earth is more in the equator region compared to the pole region. Because R is small in the pole region, G is more in the pole region. This is the takeaway. Summary. For most calculations, we take G to be more or less constant because we cannot go and much the accuracy level at some at our level we should go with simplified calculations, right? We always, most of the times we take G to be more or less constant on or near the, okay, for calculation purpose. But for objects far from earth, assume the object is somewhere here or somewhere here, right? It's very very far. I cannot this is not equal to r, remember, this is only r up to this point, right? Okay, up to this point it is r, right? So but now it is assumed it is distance x, so this is r, distance, total distance is equal to what? R plus x. For, okay, so that is equal to d, right? Okay, so for the objects far from earth, acceleration due to gravity force is given by equation this one, 9.7, where distance is equal to what? R, radius of the earth, plus this extra distance, or simply saying the distance between center of these points, center of these points and center of these points, which is what is the distance? It's equal to radius of this plus the distance of this object from this, right? That's one. This is summary of gravity, acceleration due to gravity, and free fall. Let's calculate the value of G. Okay, we already learned, derived the formula for the G, right? What is G? G is acceleration, remember. Instead of using A, I'm using G because this acceleration is caused due to gravity of the earth. So this is acceleration due to gravity. Okay. So let's calculate the value of G. We should put in the okay, to calculate the value of G, we know the formula, right? What is the formula? So what is the formula? We need for the formula contains we G, okay, constant, mass of the earth, and radius of the earth. Let's see, let's list out what are those, the constant and the numbers, right? So what is G? G is a, I told you, proportionality constant we derived, right? We added, right? So it's also called as universal gravitational constant. This way it's universal, it's up, this number is constant anywhere on the universe, anywhere on the universe, not just on earth, remember. So we call it as universal, but this is a constant. So what is the number here? Is 6.7 into 10 to the power of minus 11 Newton meter square per kg square. All right, it's given, right? Generally in the exam also, if these numbers will be given, no need to balance, right? But make sure better we have a look at the the what do you call units of it. Remember, always units are important, right? So then what is the next one required? Mass of the earth. Again, what is that mass? So into 6 into 10 to the power of 24 kg. Look at the unit kg, right? So now what? Radius of the earth. Of course we need radius, right? Because we are talking about g. All right. So what is radius of the earth? Is r is equal to 6.4 into 10 to the power of 6. 6.4 into 10 to the power of 6 meters. Remember the unit. Look at the unit. Meters. Look at the unit. Meters. If it is in 6 kilometers, we have to convert into meters. Remember. Always remember that. Okay, now let's use the formula we derived some time back, right? What is G? Acceleration due to gravity is equal to this universal gravitational constant G into m by r square, which is equal to, what is that? 6.7 into 10 to the power of minus 11, 6 into 10 to the power of 24, and 6.4 into 10 to the power of 6 whole square, right? Remember, we just substitute the given values in our formula, that's all. Now, can I see, just to be, simplify our mathematics, I'll take the, the numbers separately, and these numbers, 6.7, 6, and 6.4, I took them separately. Okay, it's easy to calculate. Okay, and I take this, the powers, the exponential numbers, or 10 to the power numbers separately. All right. So how are those? What are those? See, look at it. 10 to the power 24, 10 to the power 24. 10 to the power 6, 10 to the power 6 square, remember, 10 to the power 11, 10 to the power 11. Now it's easy to simplify. We know the so-called formulas, right? Okay, what is this? Okay, what is this? You know the formula. 6 into 6.7 is equal to 40.2, and 6.4 into 6.4, right? That is equal to 40.96 into 10 to the power. Look at it. When you are multiplying a powers of the same base, we always add the powers. Remember, correct? You know the formula, right? What is the formula? For example, x to the power 2 into, remember, into x to the power 5. If it is like that, look at it. It is into multiplication, right? We add the powers. This is a property we learned, right? So what is equal to x is equal to how much? Is equal to 2 plus 5, 7x. This is a formula we know, right? So let's use the same formula here, apply the same formula here. So now using the same formulas here, what do you call 10 to the power minus 11? Okay, 10 to the power plus 24, add it. See, because see, look at it. What is this formula? So assume for a moment x to the x square whole to the power 5. What do you do? We generally multiply x is into 2 into, here in this case we multiply, so that is equal to x 10. There is a difference, remember. So in this case 10 to the power 6 whole square is equal to 10 to the power of 6 into 2, which is equal to 10 to the power of 12. See, right? 10 to the power of 12 I wrote. Okay, these are few mathematical terms we should be already knowing. Okay. Right, so done. Perfect, right? So now let's solve it now. So what is this? See, 10 to the power of minus 11 minus 12. How much it becomes? 23, right? Minus 11 minus 12 is minus 23. Minus 23 plus 24 is 1. 10 to the power of 1. 10 to the power of 1 is 1. If I divide this, it becomes 0.9814. Into 10, 9.814. You get it. Okay. So, the value, the value of acceleration due to gravity is 9 pi. Simplified it. So of course, this is a bigger number with more decimal points. Let me simplify it. Okay, 9.8. We can say 1 also again. 9.8 meter per second square. This is how we derived. And remember, this is a constant on the Earth. What is g? G is the acceleration. It means the acceleration due to gravity. Acceleration of what? The rate at which a falling body, is accelerating towards Earth is 9.8 meter per second square. And whether it is a big heavy body or a light body, doesn't matter. All of them, all the bodies accelerate towards Earth at this rate is a takeaway from this slide. Okay, class. This topic. Okay, let's understand motion of the objects under the influence of gravitational force. Okay, now how objects, see, you drive a car. Okay, you're driving, accelerating, it moves, but it is also attracting. How it happens? You're sliding. Okay, how Earth is affecting it. Some flight is moving, flying, and Earth is also attracting downwards. Now, all these behaviors. Okay, motion of the objects under the influence of gravitational force. Okay, all right. So an object, let's summarize it first. Understand, get a glimpse of what these topics. An object experiences acceleration during free fall. You know what is free fall, right? Free fall. If an object is under free fall, it is not falling at the same speed. It is falling, but it is not falling at the same speed. It is as as the object moves towards Earth, it is accelerating. Okay, but accelerating at the constant rate, 9.8 meter per second square. But speed is increasing, remember. Okay, an object experiences acceleration during the free fall. It's very clear, right? It's accelerating. Look at, many people are sliding, driving, flying, so many things, and everybody was, facing this gravitational force is influencing everyone, right? This acceleration is independent of its mass, I mentioned, right? Acceleration is independent of its mass. It means if a 1 kg, iron is free fall, under free fall, it faces it undergoes a same acceleration, 9.8 meter per second square. Even if feather is under free fall, feather which is lighter, that is also under the same acceleration, 9.8 meter per second square. It means, see, the 1 kg iron, the weight, right, and just a few grams of feather leaf, right? Huge difference in mass, but both will have a same acceleration due to phase acceleration when they approach towards Earth. This acceleration is independent of its mass. So what is the formula? Look at it. That's the formula. It's very evident from the formula itself, right? What is acceleration due to gravity? G is equal to capital G into m by r square. Where is G? G is the universal constant, independent of mass. M is mass of the Earth, not the mass of this object falling. Okay, mass of Earth is anyway constant given to you, and radius square, that's also constant, right? So it means all three constants are given. G is constant. Okay, it means, okay, it is independent of mass. That's what I said. There is no the mass of the falling body in this equation. Okay, all objects hollow. All objects hollow. Take a hollow objects or a solid objects, a big object, a small objects. No, I mentioned, I gave you, right, feather, or iron, or a balloon, or whatever, right, or some stone, whatever it is, right? All objects, different sizes, big or small, hollow or solid, fall at the same rate. What is the fall at the same rate? It's 9.8 meter per second square. That's acceleration. Right. So, and I think the Galileo's, your people know about him, right? There is a story where it's mentioned that Galileo dropped, different objects. See, I'm showing you some, the planets kind of a picture, but imagine some bars with you. Okay, I'm, right. So Galileo dropped different objects from the top of the Tower of Pisa in Italy. The what do you call that, leaning tower. See this. This is. I mean, don't worry. That doesn't matter for us. But this Pisa Tower is very famous, right? Tower of Pisa in Italy, right? He dropped, different objects on the top just to prove, understand how what rate they fall. Okay, just to prove the same. Okay, next. It's a story anyway. I just wanted to cover it, right? So, but as G is constant on near the Earth, right? So G is constant near the Earth, right? So G's acceleration due to gravity is constant near the Earth. all equations for uniformly accelerated motion of objects become valid. You know that, right? Three equations, right? So we derived three equations for the motion. Okay, we'll cover them later. Now we can simply replace a in that equation, those equation, in these things, because these are the three equations. I'll cover them in a little bit detail in the next slide, but for now take these three equations. They are very, very important equations. In these equations I can simply replace a with g, because both are accelerations. But in this particular case, for an oblong object, uh, I can simply replace it with acceleration due to gravity, because we know the acceleration value, right? It's constant, 9.8 meter per second square, right? So these are still valid. Okay, v is equal to u into, what do you mean by u? U is a initial final, sorry, u is a, sorry, v is a final velocity. Okay, velocity of the object falling. What is u? U is the initial velocity. It started with what velocity? It started at it, at if the ball started falling at with at from inertia at u is equal to 0 at no velocity, right? It can be some, it can have some number, right? V is equal to u plus at. T is a time and a is acceleration. I can simply replace it. V is equal to u plus gt. I can write now, right? Right. Similarly, we have uh, similarly we have yes, distance covered in time as displacement, we call it as, this displacement. So these are these equations we'll deal in later, but we already, this is not these equations are not the subject of this chapter, but you should know them, how g can be replaced here with from replacing a. Okay. Note, in applying these equations, we take acceleration A to be positive. A is positive when it is in direction of velocity, that is in the direction of motion. Remember, assume body is moving this way, okay, and it's speeding up in this way. So if I'll take this as a positive, it is moving in this direction. Actually, a to be positive when it is in the direction of velocity and in the direction of motion. Sometimes a can be negative. A will be taken as negative when it opposes the motion. Assume the motion of the body is this direction, but your acceleration is such a way that it opposes it. We say is negative. Okay. Okay, recap. What is recap? Because I thought of covering those three equations. That's what I wanted to mention. At the same time, give some introduction about Sir Isaac Newton. Okay, this is not really part of this, the chapter, but better you guys knows it. Okay, Sir Isaac Newton is considered the father of mechanics. You know, just Google what is mechanics. It's a big branch of the science. Okay, um, uh, right, so and mathematics, of course, right. So kinematics is a sub branch of mechanics. Okay, and in kinematics we study the motion without considering the forces that cause it. Assume this object, it's falling. I'm not, nobody's throwing it, putting a pressure, just dropping it. So dropping means not applying the pressure, just dropping, right? All right. So kinematics is what? It is a branch of mechanics, right? And it's a study of motion of objects. Remember, without considering the forces that cause it. Okay, and some more. First, who is Sir Isaac Newton? Let's go one or two lines more, right? Sir Isaac Newton, okay, gave the fundamental physical laws. It's a fundamental physical laws that deal with objects and their motion. He's the first guy for all the reasons to quote them in a laws, capture them in a physical laws of physics. Okay, laws of nature. Physics is the nature. Remember. Okay, the first law, the fundamental physical laws that deal with objects and their motion is the first to give. Remember. Okay. Uh, and he gave three laws of motion. Okay, and he formulated in the year 1686, 17th century, three laws of motion which change, that's why we called as father of mechanics. Okay, right. So his three laws he was able to formulate in his book Principia Mathematica Philosophia Naturalis, right? So, yeah. So these are some introduction about him. Let's come back to our subject. Okay, what are the three laws? Yeah, I mentioned, right? What are the three fundamental laws of physics which Newton, gave, right? So what are the first law? First law was Newton's first law was an object at rest stays at rest. Sorry, an object is staying at rest, it stays at rest. An object in motion stays in motion, right? If object is at rest, it will remain in rest. If object is in motion, they remain in motion with the same speed, right? Object in motion at some speed will remain in the same speed and in motion. Remember, okay, and in the same direction, okay, unless this word unless acted upon an unbalanced force, unless acted upon an external unbalanced force. Okay, this is the first one. Okay, second law of motion says the force along the force acting on an object, assume there is an object, a ball, a forcing acting on an object is equal to the product of its mass and acceleration. Force is proportional to mass and acceleration, which we use the formula again and again in our previous derivations, right? Okay, the force acting on an object is equal to the product of the mass of the object and acceleration. Okay, all right. Second, third Newton's law is for every action there is an equal and opposite reaction. It's world famous, right? It's sarcastically used in many places, right? Of course, it's a physics law. Okay, for every action there is an equal and opposite action. I don't think I need to explain these things because they are pretty much covered in your other top chapters. Okay, let's go further. So now look at it. The equations of motions. Now we are not. These are laws. Remember. Okay. Law 1, law 2, law 3, and three equations of motions arose are derived. Okay, from this Newton's second law of motion. What is the second law of motion? F is equal to ma, right? People or Newton himself, you derived three new laws of motion using this fundamental second law of motion. Okay, the equation of motion from this law of motion, right? The equations of motion arose from Newton's second law of motion. These equations are a means to quantify and predict the motion of the objects because everybody is moving, Earth is moving, planets are moving, sun is moving, we move, everyone is moving, right? So how do you quantify? How do you predict the motion of these objects? Okay, under constant acceleration, right? There's one catchword is acceleration is constant, it is assumed. But these equations are a means to quantify and predict the motion of the objects. Right, what are those equations? Equation is one is v is equal to u plus at. What is v? V is equal to final velocity. Okay, what is u? U is the initial velocity. As the object is moving, it starts with at some velocity and it ends with some velocity. Okay, those are final and initial velocities. What is acceleration? It's a rate at which it's a rate of change of velocity. Remember, acceleration. Okay, assumed to be constant. In this condition, all in these equations, a is assumed constant, and t is of course time. And second equation is what? S is displacement is equal to ut. U stands for initial velocity, time, into plus of at square, right? So now S is the displacement. How much body got displaced? How much distance it traveled? Okay, that is again given by ut plus half at square. What is third one? Okay, v square is equal to u square plus 2as. Look at it's combining velocities with displacement. Okay, see there is no time here in this term. Okay, see we have a time, use displacement. You have a don't have a time here, displacement. Use this equation to displacement or velocity depending on the conditions, right? These are three important equations I thought of give. See, I'm not deriving them. I'm not getting deep into it because I thought I'll connect them to you people because these are very important equations which we will be using it for our calculation. Right? I'm not deriving them because they're not part of this chapter. Now let's solve some problems. Let's use Newton's equations of the motions and try to understand the motion of the objects. Say for example, what is the velocity of the car moving, or how much time the car took to reach some distance, what is the distance it is traveled, how much time it took to reach the distance, something like that, about motion of the objects. One of the problem which I'm considering, taken from the book, remember, is imagine a car falls off a ledge. Imagine itself as a ledge. This is ledge, and it falls off to the ground, right? Okay, but how much time it took fall? Zero point 0.5 seconds. It took 0.5 seconds to fall. They given that the acceleration due to gravity is 10 meter per second square. Remember, this acceleration due to gravity we just calculated previously. Actual value is 9.81 meter per second square. But in the book they are given 10 meter per second square. I'm taking the same thing. They have given 10 just to make your calculations simpler, so that you don't need to spend too much on mathematics rather than understanding physics. Okay, that's what they given it. uh, Now what is that you need to calculate? You need to calculate, what is that you need to calculate? Okay, you need to calculate the speed, you need to calculate the average speed, you need to calculate the height of the ledge. Okay, let's go on by further deep. As you know, we have to list given things. At the same time we have got three problems, right? So right, look at it. In the solution, in the first problem, we need to calculate final velocity. What is final velocity? Well, see, this is initial velocity, and this is the final velocity. Remember, we already told you the velocity of the car is not constant throughout the journey toward the fall. Yeah, the car is approaching the earth, it accelerates. Okay, what do you mean by accelerating? It is increasing the speed, it is increasing the velocity. It means this velocity is this velocity is more than this velocity. This velocity is more than this velocity. This velocity is more than this velocity. The car is increasing the velocity as it moves towards the earth. Okay, and we have an initial velocity here, and we have a final velocity here. That's what I wanted to say. That now what question they're taking is calculate the final velocity of the speed, right? What is the final velocity of the speed? Next, what is the average velocity of the average speed of the car? I told you speed is not constant, so when sorry speed is not constant, speed is changing. So when you want to speed, I want to say what is the speed of my car, and it's not a single number, right? Generally we take an average and tell you because it's the speed of my car. So then out, what is the speed of my car during the fall? Whole region, remember, average of it, right? What is third one? What is the height of this ledge? Okay, height of the ledge. Of course, what is the height of the ledge? Of course, this is also equal to the displacement of the car. How much car got displaced? How much car got moved or filled? What distance? That's the displacement of the car. Now by three equations of motions of we know this formula. We can simply calculate. Okay, we know the problem statement. Now let's get into solving it. What is this? What is this? What is given? Given time is equal to 0.5 seconds, off seconds. Why? So it means what is the meaning? Car took half seconds or 0.5 seconds to reach the ground. Time is very clear. Okay. Okay. What is initial velocity? Assume car was in and rest, and something happened. It fell down. Small initial velocity. I'm taking it 0 meter per second. Okay. And what is acceleration due to gravity? See, it's given to you. Acceleration due to gravity is plus 10 meter per second square. Actual value we calculated just now is 9.81 meter per second square. That's a proper number. But in the book, just to shift your focus from pure calculations to the understanding mathematical laws, or sorry, physical laws, they are given a simpler number, approximated number, which is meter per second square. Let's go with 10 meter per second square. Okay, so that our focus will be more on physics than solving mathematics problem, right? Acceleration due to gravity is 10 meter per second square. Now look at it. Let's take acceleration of the car. For what is important? What I'm interested in, acceleration of this car, right? So now acceleration of the car is, I'm taking positive 10 meter per second square. I told you, right? Any object, heavy or light, hollow or a solid, every object, they accelerate at the same rate, which is 9.81 meter per second square. I told you, right? That's a constant, right? But in this case, we are interested in accelerating the car, right? What generally I take same rate, 10 meter per second square, correct? The car is accelerating towards the earth at the constant rate, 10 meter per second square. But the sign is impied many times, right? Remember why sign is impied? Why sign is impied? Look at acceleration due to gravity. Acceleration due to gravity is what? It is towards down, and car is also moving towards down. Earth is attracting towards, car is also moving towards down. I'll take it as a positive. Okay, in case in some other problems for some reasons assume the car moves up, then I'll take the negative number. In this case, car is moving down, which is same as the sign of this 10 meters per second, so which is I'm taking it positive. Okay, right? Why I took positive? It's important. In some problems we'll take negative also, keep it in mind. Okay, right? So now now we understood the background and what are the signs we need to take, what are the values are given to us. Let's get into solving the problems. Let's go with first one. What is the first one? What is it we need to calculate? Final velocity or speed of the car. Okay, we have three equations. Let's solve one by one. Which one? We have three equations, right? One is v is equal to u plus gt. Other two equations contains s term, displacement. We don't know the displacement till now, right? Displacement is this height. How much far, how much distance car traveled, or to what distance it fell, right? S is not given to you. So I will not be using second and third formula. I'll be using first formula because this formula doesn't have a s term, displacement term. And we have all the term available. V is final velocity, which I need to calculate. Okay, and what is u? U is initial velocity. We know it is 0 because it was on rest. Okay, and what is time? Of course, it took half a second to fall. And what is g? G is given, which is a constant. Acceleration due to gravity is plus 10 meter per second square. Then substitute them. So remember, this is the first equation of motion. And to recall, we derived three equations of motion from the second law of Newton's law. Okay. Okay. So now substituting 0, g is 10, time is 0.5, we get, okay, v is equal to 5 meter per second. Remember the unit. The unit of velocity or the unit of speed is meter per second. How many meters it traveled in a second? Okay, meter per second. So what is solution? What is the answer? Now the final velocity or speed of the car on striking the final velocity is same, right? Final velocity is this much. Okay, or you can also say that speed of the car on striking the ground, that's the final velocity, right? Which is equal to 5 meter per second. And we solve the first problem. Let's go to the next problem. All right, second, what is that they are going to ask? They are asking us average speed of the car. I told you just a few minutes back, I'm repeating again and again, the speed of the car is not constant. Acceleration of the car is constant, which is 10 meter per second square, but the speed of the car is not constant. I told you, covered many times in this line. Okay, and what is happening? Is it reducing or as the car approaches? No, the speed of the car is increasing as the car approaches towards the ground. And I told you why also. Two reasons to put it. Okay, as V is equal to GT, one formula. Otherwise, F is equal to G into MM by D square. We can use understand by both the formulas. Because it's already covered there. Now, how do you find? Because since velocity is changing, right? So how do you find, if someone asks you what is the speed of the car, we have to find an average because it's not a single number available there, right? Since the speed is changing at a constant rate, right, which is 10 meter per second square, speed is changing at a constant rate, it is good, it's okay to take average of initial and final values. Okay, what is the initial values? U is, and what is the final velocity? V, and after average is divided by 2. Divide that sum by 2, right? So you see, this makes sense because speed is constant, sorry, acceleration is constant, or speed is changing at a constant rate, right? So now what is initial velocity? 0. What is final velocity? 5, because we calculated here. right? Then average of it, divide by 2. What is that? 5 divided by 2 is 2.5 meter per second square. Then final answer, the average speed of the car during the fall. No, no, you ignore this sentence. Average, it's all our fall, right? No, average speed of the car during the fall you can write, no issues. Okay, average call is 2.5 meters per second. Now, this is the second problem now. Let's go for the third problem. Right. What is the third problem? What is the required? It is they're asking us to calculate the height of the ledge. Of course, this is the height of the ledge. It is also generally car falls like this, right? So we can say that if I find the displacement of the car, it is also equal to the height of the ledge. Perfect. Let's calculate the displacement of the car. And we can and then look at the height of the ledge. Right? How? So now what is the distance traveled? So there is the equation. The two equations are S is equal to what? Ut plus of gt square. What is this? This is not third law of motion. This is the third equation. Yeah, what is this? This is the third equation. This is first equation. This is the third equation. Okay. Right. Third equation. So now distance traveled is equal to S is equal to ut plus of gt square. Now, then what is that? Substitute them. U is equal to 0. T is of course 0.5. Of fine. G is 10 meter per second square because they're given, we are using it. And what is T square? 0.5 square because it's given. Of seconds it fills. Right. Solving it. Right. What is off into 10 off into 10 into 0.25. 0.5 into 0.5. You get 0.5 into 0.5. Remember that is equal to what? 5 5 is 25. So there is a one dot here, there is one dot here, right? With one number after a dot, right? So then 1 2 is put here. So 0.25. Okay, so clear, right? So now what's happening here? So half into 0.25. Okay, how much? 5 into 0.25. It means that is equal to 5 into 0.25. How much? 10 by 5. 10 by 2 5. 5 into 0.25. Or just do that. Okay, it becomes 125 and dot 2. 1.25. 1.25, what is the unit? It's a distance, right? The unit is meter. Okay. So now what? What is the solution? The height of the ledge is equal to displacement of the car, correct? We told you. And that is equal to 1.25 meters. Okay. Let's solve the next problem now. Let's solve some more, the problems. Okay. Again, these are taken from a book. Okay. Example 9.3. So, an object is thrown vertically upwards. Look at it. An object, assume a ball, is thrown vertically upwards. Okay, okay, and rises to a height of 10 meters. Assume this height is 10 meters. Okay, calculate. What is it? Calculate. We have to calculate the velocity with which the object was thrown, the speed at which the object was thrown upwards. Second, I need to calculate time taken for the object to reach the maximum point. This is a maximum point, assume. Okay, to reach the height. You need to calculate the time. You need to calculate the velocity. Okay, then let's as we do, right? Then regularly. So we need to list the given data here, data basically, and we have to find solution one, solution for question one, solution for question two, right? So what is given? Okay, oh yeah, let's do this also. What is the first one? As a part of the first question, what is that the solution? And they need the velocity with which the object was thrown. As part of the second question, what is the solution they need? Time taken for the ball to reach the highest point, right? Now let's go. So what is given? What is given? Simple, right? What is given? We know it already. What is given? Distance traveled is 10 meters because this guy throws a ball and ball reaches 10 meters. Assume it started from here. Okay. Don't worry. Don't get exactly according to the equation. Velocity is okay, but thrown upwards. Okay. Distance traveled is 10 meter. Okay, and what is the final velocity? Of course, the moment it touches this, okay, it stops and then it falls back, right? At this peak point, the velocity is zero, where hmm, final velocity is what? Mid 0 meter per second square. Okay, so acceleration due to gravity is how much? What is acceleration due to gravity? Constant, right? 9.81 meter per second square. We derived it. This is acceleration due to gravity. It is constant for an Earth, on the Earth. So now it is something interesting. We need to you need to be thinking this where we people might do mistakes. Just covering it up. All right. See, look at the acceleration of the object. See, the Earth is attracting the acceleration due to gravity. What is the direction? Our acceleration due to gravity is downwards, which I take it as positive. Correct. But what I'm interested is acceleration due to acceleration of the ball. I'm interested in acceleration of the ball. Earth is this way, right? If the ball is moving, if the ball is falling, okay, I'll take it as a positive acceleration of the ball. If the ball is moving upward, it means it's against the attraction of the Earth, right? I'll take it as negative in the opposite direction. Correct? So now, since what I'm interested is ball is thrown up, they want us to know the velocity with which the ball was thrown up, how much time it took to reach up. It's all in the opposite direction, right? I'll take acceleration to be negative, but magnitude is same, 9.8 meter per second square, minus an into upward direction. Okay, clear? Now let's do one thing. The given is clear, so be careful. Summarizing again, if your ball is moving up, take negative acceleration. If the ball is coming down, take positive acceleration. But acceleration value is constant for any object. Take a ball or a car or a man or whoever. It is constant, 9.8 meters per second square. Okay, right. So now solution one. What is that they want to know? They want to know velocity with which the object was thrown. There are two equations, right? V is equal to u plus 2at. Other one is v square plus e square plus 2as. Look at it. Time is not given, so let me not use the first equation. Second law of, no, again wrong here. It's second equation of motion. Equation. It's not a law. Okay. Second equation. Right. V square is equal to u square plus 2as. Right. What is u square? It's a final velocity, which they want us to know. Oh, no, final velocity is got given 0, right? At this point, what is the velocity? It is almost stagnant, 0, right? So final velocity. And what is initial velocity? You have to throw with some initial velocity, right? Then only ball rises. So what is the initial velocity? Yeah, I need to calculate. And of course, 2 is constant, a is acceleration, okay, and s is of course displacement. What is the displacement? Whole height is 10 meters, right? So now let's calculate it. Mm, mm, mm. Right. So now what is final velocity? We know that, right? 0 here, velocity. And what is initial velocity? I need to calculate u square. Then 2, what is this a? I took minus 2.8 because opposite direction compared to the earth attraction, right? And what is displacement? 10 meters I took, right? What is the maximum height reached was 10 meters, right? So now v square is equal to, it comes this way, or change the directions, it is minus becomes plus. So what is that? U square is equal to 2 into 9.8 into 10, or okay, 98 into 2, or whatever, you know the mathematics, right? So what is u square is equal to how much? 196. 9.8 into 2 is 119.6. Okay, that's 196 into 10. Right. Hmm. U square is equal to 96. What is u then? Square root of it. What is square root of it? 14. You know how to take the square root, right? 14. Okay, 14 into 14, 196. So we'll cover that, taking square root in some other class. Okay, if you don't know. So the answer is what? The velocity with which the object was thrown upwards is 14 meter per second. Remember the unit. It's a meter per second. We use the second equation of motion. Okay, equation of motion. Solution. Now let's go for a second problem. Let's find a solution of it. What is that required? They want to calculate time taken for the ball. First equation contains first equation. Correct. First equation contains the t term. Correct. V is equal to u plus at. So now we know initial velocity we calculated, which is 14 meter per second square. Final velocity we know it is 0, and acceleration is given minus 10 meter, 9.8 meter per second square. Time we can calculate, correct? So now let's solve for time. 0 is equal to u is 14 minus 9.8 into t. Right. What is time? Time is equal to 1.43 seconds. You should be able to know the divisions and manipulations. I'm not covering it here, right? So 9.8t comes to the left. So 14 divided by, it becomes 14 divided by 9.8. Okay. 14 divided by 9.8 is 1.43 seconds. Right. So now what is the answer? Time taken for the ball to reach the highest point is 1.43 seconds. The unit of time, remember seconds here. Okay, okay, done. We are done with a couple of problems. Okay, now let's answer some questions. Okay, to summarize it. What do you mean by free fall? What do you mean by acceleration due to gravity? Which I already covered, but let's recall and answer them in a proper way. Okay, what is the first one? What do you mean by free fall? Remember free fall. Free fall is when objects fall towards the earth. What is free fall? Free fall is when objects fall towards the earth only under the influence of gravity. Important word. Only under the influence of gravity. When objects fall only under the influence of gravity, we call it as a free fall. And free fall is free fall does not consider other forces. For example, air resistance, friction, etc., etc. It will ignore. It will not consider other forces. What is free fall? Free fall is an ideal situation that rarely happens in real life because our environment, for example, it has the air and it provides some amount of friction. Right? It's an ideal situation. Free fall is right. So for all the reasons, in our approximate calculations, we ignore air resistance and friction. We give an object is falling without external force visible apparent. We say free fall. Okay. Now, what do you mean by acceleration due to gravity? Acceleration is that rate of change of velocity, correct? Acceleration is what? Rate of change of speed also you can say that. Rate of change of velocity. It means delta velocity by delta time. Or you can say V final minus B initial divided by T final minus T initial. Okay. Don't worry about it. Okay. Okay. The acceleration is the rate of change of velocity. Acceleration due to gravity is the increase in speed caused by the gravity, correct? What is acceleration due to gravity? Okay, acceleration we understand, rate of change of velocity, right? Rate of change of velocity, the rate of change of velocity, it means velocity changes, right? Velocity can increase, velocity can reduce, but it changes. The question, acceleration is change of rate at which velocity changes. That's acceleration, right? Then what is acceleration due to gravity? Is the increase in speed. We know that it will not decrease. We know for sure. We see it, right? Acceleration due to gravity is the increase in speed. Okay, increase in speed caused by gravity. Okay. Okay, for a falling object, remember. Okay, acceleration due to gravity is the same for all objects. See, acceleration due to gravity, G I said, right? Acceleration for gravity is common or same or constant for all objects, regardless of their mass. Remember, maybe a elephant is falling, maybe a feather is falling, maybe a 1 kg, iron weight is falling, or a small stone is falling. Doesn't matter. The acceleration due to gravity, it's the rate at which these are accelerating towards Earth, right? It's constant, okay, regardless of their mass. Acceleration due to gravity is denoted by G. Okay, it's denoted by G. We don't no more use A, though it is acceleration. Okay, and its unit is meter per second square. And the value of G on Earth is 9.81 or meter per second square. Right. This is a summary of it. All right. Now, yeah, let's end this now. Now, in this class, we learned topic 2 of the gravitation, which is free fall, and we did a couple of calculations, finding the velocity of the car or time taken for an object to, reach some distance like that, etc., etc., etc. We learned Newton's laws of motion. At the same time, we learned three equations of the motion, which are derived again from Newton's fundamental laws of motion, right? Next topic, we'll focus on mass and weight. Okay. Thank you for your time, and have good luck for your exams.